Bathroom ventilation in multi-family housing like apartments and retirement homes is governed by several codes. The International Mechanical Code, or IMC Chapter 15, specifies ventilation requirements for bathrooms and other spaces that generate moisture. The International Residential Code, or IRC, Chapter R312, provides minimum ventilation requirements for bathrooms in residential units. The International Building Code, or IC Chapter 10, may require fire dampers in certain ventilation systems. Each bathroom must be provided with a mechanical exhaust system capable of exhausting 50 cubic feet per minute, or CFM, of air. Exhaust fans should be located on an exterior wall or vented to the outside through a roof cap. Exhaust ducts should be sized to provide the required CFM and should be insulated to prevent condensation. Fire dampers are required in ventilation systems that penetrate fire-rated construction, such as walls or ceilings. Fire dampers close automatically when a fire occurs, preventing the spread of smoke and flames through the ventilation system. In multifamily housing, fire dampers are typically installed on the exhaust ducts in bathrooms that share walls with other units. It's recommended to use low-noise exhaust fans to minimize disturbance to occupants. Install timers or motion sensors to ensure the fan runs for a period of time after use. Consider using energy-efficient fans that meet ENERGY STAR criteria. Provide access panels for maintenance and cleaning of the exhaust fan and ductwork. In retirement homes, bathrooms may require additional ventilation to accommodate the needs of elderly or disabled occupants. Consider installing exhaust fans with high CFM ratings or providing additional ventilation. Ensure the bathroom exhaust system is accessible and easy to operate for all occupants. Let's delve deeper into each of these aspects to provide a comprehensive understanding of bathroom ventilation codes in multifamily dwellings. We will explore specific sections of the codes and clarify how they apply to different building scenarios. The International Mechanical Code, or IMC, is a comprehensive set of regulations pertaining to the design, installation, and maintenance of mechanical systems, including ventilation. It establishes minimum requirements for ventilation to ensure indoor air quality and occupant health. Chapter 15 of the IMC specifically addresses exhaust systems, including those used in bathrooms. The code stipulates the required exhaust rates, ductwork materials, and installation methods for bathroom exhaust fans. The IMC emphasizes the importance of proper ventilation to remove moisture, odors, and contaminants from bathrooms, thereby preventing mold growth and maintaining a healthy indoor environment. It provides detailed guidelines on calculating ventilation rates based on the size of the bathroom and the number of occupants. Furthermore, the IMC addresses the location and type of exhaust fan to be used. It requires that exhaust fans be located near the source of moisture and contaminants, such as the shower or toilet. It also specifies the type of fan that should be used, based on its ability to provide the required exhaust rate. The International Residential Code, or IRC, provides minimum requirements for the construction and alteration of 1- and 2-family dwellings and townhouses. Chapter R312 of the IRC specifically addresses ventilation requirements for bathrooms in residential units. The IRC mandates that each bathroom be equipped with a mechanical exhaust system capable of exhausting a minimum of 50 CFM of air. This requirement is intended to ensure adequate ventilation to remove moisture and odors from the bathroom, preventing mold growth and maintaining indoor air quality. The IRC also specifies that the exhaust fans must be vented to the outside of the building. This is to prevent the recirculation of moisture and contaminants back into the living space. The IRC provides guidance on the installation of exhaust ducts, including their size, material, and routing. The International Building Code, or IC, is a comprehensive set of regulations governing the design and construction of buildings, including multi-family dwellings. Chapter 10 of the IBC addresses fire protection systems, including fire dampers. Fire dampers are devices installed in ventilation systems to prevent the spread of fire and smoke through ductwork. They are typically required in ventilation systems that penetrate fire-rated walls or ceilings. When a fire occurs, fire dampers automatically close, sealing off the ductwork and preventing the passage of flames and smoke to other areas of the building. In multi-family housing, fire dampers are commonly installed in bathroom exhaust ducts that share walls with other units. This is to prevent a fire in one unit from spreading to adjacent units through the ventilation system. The IBC provides detailed requirements for the design, installation, and testing of fire dampers. It specifies the type of fire damper that should be used, based on the fire rating of the wall or ceiling it penetrates. It also requires that fire dampers be inspected and maintained regularly to ensure they are functioning properly. Ventilation rates for bathrooms in multi-family housing are typically specified in terms of CFM, which represents the volume of air exhausted per minute. The required CFM depends on the size of the bathroom and the number of occupants. Codes typically require a minimum exhaust rate of 50 CFM for bathrooms and residential units. However, higher exhaust rates may be required for larger bathrooms or bathrooms with multiple fixtures. To determine the appropriate exhaust rate for a particular bathroom, it is important to consult the applicable building codes and manufacturer specifications. Exhaust fans should be selected based on their ability to provide the required CFM. It is also important to consider the noise level of the fan, as noisy fans can be a nuisance to occupants. Exhaust fans are typically located on an exterior wall or vented to the outside through a roof cap. This is to ensure that moisture and contaminants are exhausted directly to the outside and do not recirculate back into the building. When venting exhaust fans through a roof cap, it is important to ensure that the cap is properly sealed to prevent water from entering the building. Exhaust ducts should be sized to provide the required CFM and should be insulated to prevent condensation. Undersized ducts can restrict airflow, reducing the effectiveness of the exhaust system. Uninsulated ducts can lead to condensation, which can cause mold growth and damage to building materials. It is important to use the correct size and type of ductwork for the application. Metal ducts are typically used for exhaust systems, as they are durable and resistant to moisture. Ductwork should be properly sealed to prevent air leakage. Fire damper systems are an important component of fire protection in multi-family housing. They are designed to prevent the spread of fire and smoke through ventilation systems. Fire dampers are typically installed in exhaust ducts that penetrate fire-rated walls or ceilings. When a fire occurs, fire dampers automatically close, sealing off the ductwork and preventing the passage of flames and smoke to other areas of the building. There are two main types of fire dampers, static and dynamic. Static fire dampers are designed to close when the airflow in the duct stops. Dynamic fire dampers are designed to close even when the airflow in the duct is maintained. The type of fire damper required depends on the specific application. Fire dampers must be tested and certified to meet industry standards. They should be inspected and maintained regularly to ensure they are functioning properly. In addition to code requirements, there are several recommended practices for bathroom ventilation in multi-family housing. Using low-noise exhaust fans can minimize disturbance to occupants. Install timers or motion sensors to ensure the fan runs for a period of time after use. Consider using energy-efficient fans that meet Energy Star criteria. Provide access panels for maintenance and cleaning of the exhaust fan and ductwork. Timers and motion sensors can help to ensure that exhaust fans are used effectively. Timers can be set to run the fan for a specific period of time after the bathroom is used. Motion sensors can automatically turn on the fan when someone enters the bathroom. Energy-efficient fans can help to reduce energy consumption. Energy Star certified fans meet strict energy efficiency guidelines set by the Environmental Protection Agency, or EPA. Access panels can make it easier to maintain and clean exhaust fans and ductwork. This can help to ensure that the system is functioning properly and efficiently. For retirement homes, bathrooms may require additional ventilation to accommodate the needs of elderly or disabled occupants. Consider installing exhaust fans with higher CFM ratings or providing additional ventilation. Ensure the bathroom exhaust system is accessible and easy to operate for all occupants. Elderly and disabled occupants may have difficulty operating standard exhaust fan controls. Consider installing remote controls or automatic controls to make the system easier to use. Additional ventilation may be required to address specific health concerns, such as respiratory problems. In conclusion, bathroom ventilation in multi-family housing is subject to a variety of codes and regulations. By understanding these requirements and following recommended practices, you can ensure that bathrooms are properly ventilated, protecting the health and safety of occupants. Always consult with a qualified professional to ensure that your ventilation system meets all applicable codes and requirements. Remember to always consult the latest edition of the codes and any local amendments that may apply in your jurisdiction. Firstly, ventilation in bathrooms is essential to remove moisture, odors, and pollutants. Secondly, adhering to the International Mechanical Code, International Residential Code, and International Building Code ensures compliance with ventilation standards. Thirdly, exhaust fans play a crucial role in removing air, and their placement should be near moisture sources. Fourthly, fire dampers are critical in preventing the spread of fire through ventilation systems in multi-family dwellings. Fifthly, regular maintenance of exhaust fans and ductwork is vital for optimal performance. Sixthly, consider using low noise and energy-efficient fans to minimize disturbance and energy consumption. Seventhly, timers and motion sensors can help automate exhaust fan operation. Eighthly, in retirement homes, additional ventilation may be required to cater to the needs of elderly or disabled residents. Ninthly, ensure that exhaust systems are accessible and easy to operate for all occupants. Tenthly, always consult with local building codes and qualified professionals to ensure proper ventilation in bathrooms within multi-family housing units.